Alright, let's look at the homework 1.2, problem number 8. Alright, it says that the monthly cost of driving a car depends on the number of miles driven. Right? It says that it costs her $420 to drive 400 miles and $516 to drive 720 miles. Right? Part A, express the monthly cost of C as a function of the distance driven D, right? Assuming a linear relationship. Right? So let's do that. Alright, so in this case, instead of x and y, I'm going to use D and C. So let's find a couple points. So I'm going to call it D1, comma, C1 instead of x1 and y1, and also D2, comma, C2. Alright, so first point is right here. Shows up right there. Alright, so 400 miles, so that's the distance. So D1 is going to be 400. And its corresponding cost is 420. Right? And D2. Alright, distance is 720. And the cost is 516. Alright? So once you have those 2 points, then we can come up with the slope, right? Slope m, right? So remember that the c is like y and the d is like x. So slope formula would be c2 minus c1 over d2 minus d1, right? So then we just have to crunch numbers. Alright, so C2 is 516 and C1 is 420, and let's see, D2 is 720 minus D1 is 400. Alright, so this is going to be, let's see, so 6 minus 0 is 6, and 1 minus 2, actually, so it's going to be 9. So it's 96. Divided by, let's see, that's 320. Alright, so then I guess we can simplify this. Divide by 32, so that's going to be 3. And this is going to be 10. Alright, so it seems like a slope is 3 over 10. Alright, so once you have a slope, we can use the point slope form to find the equation. So remember, so it's a c is like y, so c minus c1 is equal to slope m times d minus d1. Alright, so from here we can get the equation. So it's a c minus c1 is 420. Alright, m is 3/10, and d minus d1. d1 is 400. Alright, so let's simplify that a little bit. So I'm going to just distribute 3/10 to these two terms. Alright, so we get 3/10 d minus, let's see, 40 divided by 10, 400 divided by 10 is 40 times 3, so it's minus 120. Alright, then we want to isolate c, so we can just add 420 to both sides of the equation. So c is going to be equal to 3 over 10 d and plus 300. Alright, so let's type this guy in. Alright, so this was 3 over 10 d plus 300. Alright, Let's use part A to predict the cost of driving 1,500 miles. So we just need to plug 1,500 for D. So let's do that. All right, so we're talking about C of 1,500. So this is going to be 3 over 10 times 1,500 plus 300. Right, so that's going to be 10 divided by that. So you're going to get, let's see, 450 plus 300. So that's 750. Right, so let's type that in here, 750. All right, then the picture, the graph is going to be, let's see, so y-intercept, I should say c-intercept is 300. So it's something that starts from 300. This is okay, this is okay, that's okay. And a slope is 0.3. And this is way too steep. This is slope is 0. So this got to be the right picture, right? And what does the let's say slope represent? So that's the not the fixed cost, and here it presents the cost in dollars per mile. So that's that. And the c-intercept is the fixed cost. It represents the fixed cost. So we have that one. And why does a linear function give a suitable model in this situation? Linear function is suitable because the monthly cost increases, the number of miles driven increases. This is true. Let's look at the other ones. The cost increases, number driven decreases. That's not it. And cost increases even though the miles driven is constant. That's not it. And the cost is fixed despite the fact, so this is not it. So the only reasonable one is the very top one. Alright, so let's submit for testing. Alright, it came back and looks like we got the part A correctly, part B correctly, part C correctly, and part D correctly, and part E correctly. Alright, so that's it. I hope that this was clear.